Yeah, the next topic of this chapter is composition of functions. Right? I have written some ABC. Don't think it is an egg or something. This is a set here. This is one set. This is another set. This is set C. I'm just going to explain of what is this. So maybe there is a function like this that travels information. Maybe let me name that function as f of x, where this has some x terms, this has some y terms, and this has some z terms. So okay. For a general term, I'm calling it as x, y, z and all. That's what. Here it comes to be g of y. Right? Because the input taken here is y, and what you are going to get is from this set. See? So what is the composition of these two functions? That's what I'm going to get. So f is a function. F is a function that is from a to b, and g is a function from b to c. It's defined from b to c, right? So what is the composition of these functions? Composition of these functions are called to be g. This is represented as a circle. That is a composition that can be read as dot g dot f of x, right? Because the input of f function is x here. Yeah, input of f function is x, so it is f of x, or I can write it as f of f dot g of y, right? I can write it as g of y. This is another opposite of that, right? So let me take only this one. That makes for me easy to see based on this diagram. What is this? This is equal to g of f of x, or I can just write there is some function like this that directly travels to this, and I will name that function to be g dot f of x. See? So if I input a value that is in the form of x, I should get a value directly in the form of z and not an intermediate that is in the form of y. That's what the use of having a composite function. So let me have an example. Example, f of x is equal to, or let me have x square, and g of x. Let me take it x itself instead of taking y, z and all. I get confused. So if I take g of x, let it be cos x. Okay. So I need to find f dot g of x and g dot f of x in both the cases. Okay. So what according to this definition? This is the definition. It's a definition, not a statement. This is a definition. G of x. This should be inside the bracket now. So it comes to be f of g of x, right? What is g of x here? Cos x. So f of cos x. That was simple. Okay, let me do the same here also. There was g of f of x. What is f of x? Is x square here. I need to just check whether f dot g of x and g dot f of x are the same, right? Because seeing this diagram, I feel that either if I come back or go in that direction, I am going to get the same two elements, right? So yeah, what I'm going to get is g of x square here, g of f of x. F of x was x square. I tried it again. So f of x, f of cos x. So in place of x, you are going to put cos x. In place of x, you are going to put cos x. This becomes cos x whole square, or what do you call as cos square x, right? This is x square. In place of x, I'm going to replace this by x square. This becomes cos of x square. So saying this, you may find that it's similar, looking similar, right? But it's not the same. Here it is cos x whole square. Here only the term, or say the angle in some terms, is squared and not the whole term, that is a cos term, right? So this is different and this is different. So it depends whether f dot g and g dot f are the same or not, depending on the types of functions, right? Based on the composition of functions, we have the first question of exercise.
1.3. Yes, the first question is f is given function that is from 134 to 125, and g is a function from set 125 to 13. So what is f dot g is the question. So here the elements given here is for the function f it is 1 2 3 5 4 1, and elements given for g is 1 3 2 3 5 1. Yes, it's very simple because it's g of g dot f means g of f of x. G of f of x is how much you need to write now. So for that, let me write in the same roster form with the help of ordered pairs. For that, first I need to go to f of x. It is g of f of x, right? F of x, yeah. So first I need to find what is f of x. So for that, let me take the first one, where f of x is here. This is the input. So 1 3 4 could be the input in the three cases, right? So let me try. What do I get? G of f of what? 1 I'll take first. F of 1. What it will be? F of 1. F of 1 is 2. Because see, this is the x term for this, and this is the y term, right? So this will be the f of x term, and this is the x term. That is or the meaning of that. So f of 1 becomes 2. That is g of 2. What is g of 2? G of 2, yes, we have here x term is 2 and the y term is 3. So 3 will be the g of 2. Therefore, g dot f of 1 is equal to 3. G dot f of 1 is equal to 3. Got it? That is the first one. Second one, g of f of, what is this next element? Here 3 is there. So this is 3. Right? That is equal to how much? G of, what is f of 3? F of 3 is 3 is here. This is f of 3. That is 5. G of 5. What is g of 5? G of 5 comes here. Here 5. This is g of 5. G of 5. So what is g of 5 is 1 here. This comes to be 1. So g dot f of 3 is equal to 1. Okay. The next term is here 1 over 3 over. Only 4 is remaining. So g dot f of 4 is g of f of 4. Right? What is f of 4 now? F of 4. Yeah. This is 4. This is f of 4. So this is g of 1. G of 1. What is 1? Yeah. This is 1. This will be g of 1. That comes to be 3. Therefore, g dot f of 4 is equal to 3. This much I got now. Let me write this in the roster form here. What is g dot f as a function? G dot f is equal to the set containing, here you have 3 elements. So let me write like this. 3 elements. You have this set now. So the first term will be, what is the input here? That is 1. What is the output you got is 3. 1, 3 is the first one. Second one is 3 and 1. 3 is the input and 1 is the output. 3, 1. So when 4 is the input, 3 is the output. 4, 3. So these are the elements that are present in the function, that is g dot f. Right? The next question is about proving. Proving using the given definition. So here the first part of that is f plus g dot h is equal to f dot h plus g dot h. So how we are going to prove this? This is very simple one. We are just using the definition of what is the dot, or what is the composition of two functions. Based on that, I am just going to take that is LHS is equal to f plus g of dot h. That is let me take this to be h of x. Okay,
So I'm taking f of g of h of x, right? So just using, this is just simple, using the distributive property. This is the common one. So it becomes f of h of x plus g of h of x. Okay. So what do I get here? F of h of x becomes f dot h of x plus g dot h of x. G of h of x is g dot h of x. That is the RHS, right? The same is going to be followed in the second part also. That is, the question is f dot h, f into h dot h is equal to f dot h into g dot h. Okay, let me take the LHS once again. Based on this definition, I am just taking f dot h, no, f into h dot h of x, right? F into g of h of x. That is what the meaning of this given definition. So we are just going to multiply using the distribution. That is f of h of x into g of h of x. That is equal to f dot h into, or let me write it as dot, otherwise you will mistaken it to be the Cartesian product or something. Let me write one dot here. F dot h into g dot h. That is equal to the RHS. Hence you can prove both of these. Now we'll go to the third question. Now we have with us the third question of the exercise 1.3. We have two subdivisions here given. So the question is to find g dot f and f dot g in both the cases. F of x and g of x is given in both the cases. So this is very simple. So if it is g dot f of x, how need to find out? Either g of f of x. What is f of x here? F of x is mod x. So g of mod x. Right? That's what you understood. Now, as the previous, how do we do? Like a given function f of x, and you're going to substitute the given thing in place of x. So instead of x everywhere, you need to put mod x, right? So you're going to do the same here. This becomes mod of phi mod x minus 2, right? In place of x, I'm just going to put mod x. This is g dot f. Now we need to find f dot g of x. What is f dot g of x comes to be f of g of x. That is, what is g of x? G of x is mod of phi x minus 2. So it becomes f of mod of phi x minus 2. That comes here. So in place of x, I'm just going to put phi x minus 2. That comes to be mod phi x minus 2. But that double mod is not required here. It comes to be the same itself. That is mod of phi x minus 2 itself. Because the absolute value comes under this first bracket, first line itself. So the second line doesn't mean anything. So it comes to be the same value again. So what is going to be in this case? The same thing. And that comes to be g of f of x. F of x is 8x cube. So g of 8x cube. So in place of x, I need to substitute this thing. So 8x cube whole power 1 by 3. So based on the law of exponents, ab whole raised to n is a raised to n into b raised to n. That comes to be 8 power 1 by 3 into x cube into 1 by 3. Or x cube whole power 1 by 3, or I can write it as x raised to a into b. So 3 into 1 by 3 comes to be 1 itself. 8 power 1 by 3 is 2. I think you know that. So this comes to be 2x. Right? This is f of f dot g of x. That comes to be f of g of x. What is g of x? Is 1 by x power 1 by 3. So f of x power 1 by 3. Wherever x is there, I need to substitute like x power 1 by 3 in this case. So here you have 8x cube. 8, let it be like that. This is Then in place of x, I need to substitute x power 1 by 3. So x power 1 by 3 whole cube. Right? So that is same as a raised to b whole raised to, okay, a raised to m into whole raised to n. So this becomes a raised to m into n. A raised to m whole raised to n is equal to a raised to m into n. That's what I'm going to use here, and also I used already here also. So that comes to be 8 into x power 1 by 3 into 3 or 8x.
So from this you can observe that g dot f of x and f dot g of x are not the same. Even here you can see, here it is 2x, here it is 8x. So you cannot conclude that both of them are same, even though they look g dot f and f dot g, right? Now we'll go to the fourth question.